Okay, we're on page 10. This is lesson 4.3. We are on 4.3. Parts of similar triangles. 4.3. So we have some different things in triangles that we actually haven't talked about because for what we're doing in here, it's not incredibly important, but I am going to talk about them so that we understand what these things are called. It's not going to really affect the way we do the math, but just so that you're familiar with them. In a triangle, we have specific segments that have properties. The first is called an altitude. An altitude makes 90 degrees in a triangle. It's a segment that makes 90 degrees. So do you see here that BD creates the 90 degrees and FH makes the 90 degrees? These are called altitudes, okay? The segments that make the 90 degrees. So the rule is that if the triangles are similar, then the altitudes are also similar. So BD goes with FH. Those are your two altitudes. And then you can choose any other side. Let's choose BA. And BA is going to go with which side, do you think? EF or FE. Same thing, yeah. So it's just, again, telling us that we have more proportions. If we know the triangles are similar, then these match up as well. The next thing we have are called angle bisectors. In a triangle, you have an angle bisector. What do you think an angle bisector does? Don't think too hard. There we go. Cuts the angle in half. Okay, cuts the angle in half. And the rule says if the triangles are similar, then the angle bisectors are similar, are proportional. So QS is the angle bisector here. And UW is the angle bisector here, so they are also proportional to each other. So QS matches up with UW. And then we can pick another side. If I said QR, QR is going to match up with what do you think?
UV.
What'd you say?
UV.
UV, perfect. Brian, we're on page 10. Okay, and then the last thing we have are called medians. If you think about a median in the real world, what do you think about?
Dead in the middle of the road?
Exactly, in the middle of the road. So median goes through the middle. So it's a segment that goes through the middle. And I'm going to abbreviate through with THRU. I know that's not how you really spell it. It goes through the middle. So if we look at this diagram, do you guys see HJ is going to be the median because it goes through the middle. Do you guys see these hash marks? Meaning it's cutting it in half, right? And then what's the other median? Oh my goodness. LN. So we know that HJ is proportional to LN. And then we could also say, what if I said GJ? GJ goes with which segment there? KN. Anyone agree with Trinka? Okay. So basically, guys, it's saying the same thing, right? Put the pieces together that go together and you can make a proportion. That's what this is saying again. So let's look at problem number 1. Problem number 1, we need to find out what x is. So if we're going to figure out what x is, first we need to be able to set up our proportion correctly. And they gave me a similarity statement, so even though things are turned around, I can still make sure I line them up correctly. First of all, we have a median, because it goes through the middle. I'm going to put x with what, do you think? X goes with the 15, right? You guys okay with that? They both go through the middle. Then to say the next pair, I can choose either the 16 or the 19.2. It doesn't matter which one I choose. Let's just choose the 16. So 16, and instead of guessing, I'm going to use my similarity statement. And 16 is represented by TS. Well, what goes with TS? DE. And how long is DE over here? 20. Is everyone okay with that? Do I need to explain that again? Put your medians together and then choose one of the other sides and match it up correctly. Okay? And now we cross multiply like we've been doing. And we get x to be what? 20? Kyle says 20. Can I get an echo? 12. That's much better. Sorry, my hearing is going apparently. Hey, Monica, we are on page 10. Okay, let's look at number 2. Number 2, I have altitudes. So I have 10 going with what? 8, because those are my altitudes. So I have 10 over 8. And then because I started in 10, then I'm going to say x. Okay?
How do you know it's the altitude?
Because it creates 90 degrees. I'm not super concerned about the names of them, okay? I'm not going to ask you. But remember, it makes that 90 degrees. Okay, so 10 over 8, and because I started in 10, that means the next segment I need to say is x. It does not. Nope. X over 14. And that's the only other piece they gave me, right? So if I wanted to verify, I know that HI goes with LK, and they did match up. You can get a decimal, and it's okay. What are you getting, Brian? 17.5. Good. Okay, let's look at number 3. Actually, let's skip over and go do number 5. The next page, page 11, top of that page. Let's do number 5. We have a median because it goes through the middle.
The one on the left side always go on top?
It doesn't matter which one you put on top. It just matters that you stay consistent. So if you put that one on top, then put it on top on the other one too. Okay? So I have 2 medians. I know that 20 matches up with 12. Kara, what's going to be my next fraction if I do 20 over 12?
It'd be 2 or x minus 2 over. Wait, okay, never mind. I confused. 2x minus 9 over x minus 2.
Good. 2x minus 9 over x minus 2. So 20 is on top because these came from the same triangle and these came from the same triangle. So make sure you stay consistent there. And we know how to solve this now. What are we getting x to be? 17? I think it's 17. 17. I'll come back and help you figure it out in just a minute if you want. An algebra mistake, yeah, it happens. Okay. Do we get 17? But did you get your proportion correct? And you set it up correctly? You have 20x minus 40 equals 24x minus 108.
What now? 20x minus.
40, right?
Yeah.
And then equals
Yeah.
24x minus 108.
Yes.
Okay, so then it's an algebra mistake, and I'll help you find that in just a minute, okay? Okay, the triangle bisector theorem. So this one is a little bit different. It says if you have an angle bisector in a triangle that separates the opposite sides into two segments that are proportional to the lengths of the other two sides. Everyone's got good with that. Just kidding. Exactly, Trinka. It's a bunch of mumbo jumbo. Here's what it says, guys. If you only have one triangle, if you look at the previous 5 examples, we have 2 completely separate triangles. You guys see that? We have 2 completely separate triangles. Well, in this group of problems, we only have one triangle. I mean, it splits it into 2, but we really only have one figure, okay? So when you have one figure, and that figure is an angle bisector, meaning these angles up here are congruent, you can say that this side is proportional to this side, and this side is proportional to this side. All right? So if I were you, I would maybe highlight in different colors, or maybe you can use 2 check marks so you know which ones go together. So if I look at number 6, it says if KM represents an angle bisector, solve for X. So if it's an angle bisector, I know that these 2 angles are congruent. And I'm going to say 12 over 4.8 equals 18 over X. Anyone have questions on that? Yep. And I'm dealing with decimals in my problem, so I'm probably going to have decimals in my answer. What'd you say?
These are together, the other ones aren't.
I'm not asking you to memorize all these rules, okay? I'm asking you right now to just look back at your notes as you're doing the problems, okay? We should be getting X to be 7.2. Good. Anybody else have 7.2?
Yes.
Okay. Why don't you see if you can set up number 7 on your own?
What are we doing? 7?
Number 7. Okay, I'm hearing 48.6. Yes? Yes? Okay. Let's look at number 9. Let's look at number 9. The problem is X is representing the entire side and not just that little piece. And I can't say that 30 is over X because that doesn't make sense. I know that this side over here is 12. I know that JM is 12. What if I told you that this was 20? How would you figure out how much this was? What would you do? 20 minus 12 would be 8, right? But we don't know that it's 20. We just know that it's X. So instead of saying 20 minus 12, we can just represent this by saying X minus 12. Because whatever that x thing is, if I take away 12, that's what's left for that piece. Okay? And now it's a problem like I have been doing. So we can say 18 over 12. So I started on the left side. 18 over 12 goes to what? Brian, what does it go to? What's the other fraction going to be? Good. And we would solve that. Good. 22? Maybe I did my math wrong. Oh, here. It's 12 and you put a 2. 32? 32? You get 32, Sharmini? 32? Oh, that one's there. 32? 32. Brian, not right now. Okay, this is not correct, so try again.
Mine's not either then.
Okay.
We're not.
18 times 12.
I was right this time.
216. How do you get rid of 216?
Oh, I added it. I subtracted it.
Divided by
My
18.
bad.
Okay, you're getting 32. Excellent. Okay, I'd like you to try number 10 completely on your own.
That's what I did for doing it in my head.
That's why we don't do that in your head, especially not on the ECA.
Is the bottom number always our top number? How do
On number 10, you're going to have to figure out how much ML is first.
It's just X
Okay?
minus
Shh, not X. Look at your paper.
You don't do it the same way over here.
You do, but you don't know how much this is.
Well, if that's 27, then that's negative 27.
No.
Like right here, right?
No. I didn't know how much this whole thing was. I just knew that it was X. How much is this whole thing? You gotta put your glasses on.
You're blind. So what do you mean? 27 plus 45 maybe?
Is 27 plus 45 gonna give you that thing? The whole thing is 45, and you've already used up 27 of it.
Oh, so you minus it then.
I like what I'm seeing.
Okay. So then,
So I would just double check that these numbers are right. They should be plus.
right?
It doesn't matter. It doesn't matter how you start. It matters how you finish.
So,
You're getting X to be 17 there on number 10. If you're not getting 17, I'll come help you out. It's probably an algebra mistake. On homework 21, you need to do 1 through 11 odd. On homework 21, you need to do 1 through 11 odd.